Hello, and welcome to this install guide for a Metcal IoT setup. In this video, we're going to walk through the hardware setup, installation of the necessary software, and configuring the graphical user interface. Here is an example of a small network of 3 CV soldering stations. And as you can see, each CV station requires its own IoT module or client to send data to the user interface server. So let's see how the hardware equipment needs to be connected together. In the CV IoT kit we have, of course, the IoT module, or client as it's referred to in the software. For powering the module, a multi-region power adapter and micro USB cable are included, and for data collection from the CV station, a USB to USB data cable is provided along with a USB splitter cable should a barcode reader be required as part of the setup. Let's run through a quick schematic overview to see how each module is connected. To connect the module to your network, an Ethernet cable is required. These are not included in the kit as cable runs will be different for each installation. The provided USB to USB data cable plugs in here. The other end fits to the CV station. Finally, the module is powered by the supplied 5V USB power adapter and micro USB cable. Here we see the complete setup for a single station. The CV5200 generates the data captured by the soldering cartridge. This is then passed to the module, which in turn sends data to the applications database on the server. While the IoT module is not Wi-Fi enabled, the server can be connected to the network either by Ethernet or Wi-Fi. If your installation is to include multiple stations, you may want to consider grouping your Ethernet connections through a switcher as shown here. To add a third-party barcode scanner to your network, simply add in the USB splitter. Fit the CV cable to one input and a barcode reader to the other. You can now scan barcodes from PCBs or operator ID cards, etc. Before installing the IoT software, it is useful to know the IP addresses of each module. Hardware ID is simple, as each IoT module will come with its own unique MAC address printed on the back. However, to determine the IP address of each device, you can download a useful utility program called Advanced IP Scanner. Simply search for it in your preferred web browser. Click on the free download, then run the executable file. Follow the on-screen prompts. Answer yes. And run. If you know the range of available IP addresses on your network, you can enter them here to save some search time. Click on the scan button and wait for the table to fill. You are looking for devices under the manufacturer headed list as ASIP Technology Corporation. Once you've seen all the devices on your network, you can stop the scan. You may find the computer you are going to use as a server in this list too. If not, you can find your own IP address by using the command prompt. Click on the Windows button, type command prompt in the search box and click on the application to open it. Type ipconfig, then hit the enter key. On screen, you'll now see your IP address as well as your subnet mask and default gateway IP addresses. Write these on a piece of paper or use Notepad to save the details for later use. Also record the IP address and MAC address of each device listed as ASIP Technology Corporation. If you're using Notepad, save the file where you can easily find it later. You're now ready to start the CV IoT software installation. Open the folder where you saved it and double-click on the exe file to start the install process. Click on OK. To enable read-write access to the application, we recommend you install the application in C Users Public. Click on Next. On this next screen, it's important at first install that you click on the drop down arrow and select Complete Installation. For your convenience, add a desktop shortcut, click on Next and then Install. Installation could take a few minutes and the video has been speeded up in some places. First installed is the IoT application, followed by Visual C++. If this is already installed on your computer, just click on the Repair button to make sure it is up to date. Don't click on Restart just yet. This allows the Mongo database installation to complete. And so finally, restart your computer to complete the installation. Now that the hardware and software are set up, let's walk through how to configure the IoT modules. At first startup, the application will throw up an error message as it needs you to confirm the database location. Click on Close and you'll be taken to this screen where you can enter the necessary detail. It's useful now to refer to the notes taken previously. In this video's example, the database IP is the same as the computer you're running the software from. Simply copy-paste the IP address over. Entering localhost will also work if preferred. Set the application type to server, then click on the Submit button. After a second or two, the dashboard will appear on screen. To onboard the IoT modules, click on the Admin button, then enter Admin as the login, enter Admin once more as the password, then click on the Login button. On the next screen, click on Onboarding Devices. Enter Server, your computer, and Device, the first module, IP addresses, referring to your notes as needed. Next, we set the local time zone for accurate solver event logging. Once done, we are now ready to click through each of the process steps: Configure, Application Upgrade, Firmware Upgrade, and Unit Info. While the process is a little lengthy, it's a one-shot sequence at install and should not need to be revisited too frequently. At each step, you should see True appear as it completes. If you see a false, check your wiring and previous steps. Finally, clicking on Unit Info should show the software version and the local time if all has gone well. Close. All that remains now is to repeat these steps for each IoT module on your list. The IoT software is now ready to use. However, it's possible to enhance the experience by tagging your IoT devices with different names and other info if desired. Also, DHCP dynamically assigned IP addresses can be switched to static IP addresses should your company IT protocols dictate it. These options are available through the admin portal. Enter your credentials as before. First, we'll change a DHCP assigned device to a static address. Click on the device you want to change, then click on Detail. On this screen, click on the Configure button, On this screen, click on the Static checkbox and enter the details previously saved. Note: only use approved static IP addresses assigned by your in-house IT team. Submit the details and look for the Update Successful message. Close it and click on the Cancel button to exit the previous screen. Note: this will not show the updated IP address yet. Click on the Close button to see the data table and hit the Refresh button to update the records. The new IP address will now be shown. Now let's change the device name to make it more reader friendly. Back into Detail, overtake the current name, then click on the Update button. Close the Success Notification and Detail window. The station name is now updated for all records in the current database. This updated information is also shown in the dashboard graphics too, although a manual refresh may be required if you don't want to wait for the next automatic refresh. Finally, any changes made will be shown in the Details tab too. That concludes this install video. Thank you for watching and for your patience. If any questions remain, please refer to the written installation guide or contact your Metcal representative for further technical support.